Hi, my name is Bethany, and for Chapter 2, I decided to talk about the sixth learning objective, which is to describe several techniques for measuring brain activity during the performance of a motor skill. To start off, I would like to talk about an EEG, which stands for electroencephalography. This test is commonly used by researchers to assess brain disorders and is a non invasive and painless test. And in order for these researchers to use the machine properly, they attach multiple electrodes to the patient's scalp. An EEG measures the voltage fluctuations from thousands to millions of neuron activity. Once brain activity is detected, it is translated into waves on a recording device. There are four specific types of waves that can be detected according to the speed of the brain activity, and they are called alpha, beta, theta, and delta waves. An EEG can only detect activity that occurs in the brain cortex surface, and it does not show the actual structures of the brain regions. A PET scan is another test which stands for positron emission topography. These tests show the blood flow in the brain and allow the researcher to look closer in specific regions where this blood flow is occurring. And in order for the test to be performed properly, the patient must inhale or be injected with a radioactive solution, which puts positively charged electrons into the bloodstream. A computer then scans the area where the electrons are and analyzes the activity of the brain neurons that light up. A color spectrum is then used to determine the level of brain activity that the patient has. An fMRI, which stands for functional magnetic resonance imaging. When someone performs a task, blood flows to certain parts of the brain, and this test records and provides colored images that show the specific areas of the brain that are active during said activity. The only problem with this test is that the actions that are being performed have to be small enough to be performed in an MRI machine. A more recent test called a MEG, which stands for magnetocephalography, which tests the magnetic fields that the brain creates from a neuronal activity. It has a very high temporal resolution, which allows the researcher to scan for damaged brain tissues and is great for observing brain activity. In a sense, it is more a specific and clearer picture than what an EEG would provide. The last method I would like to bring attention to is the TMS, which stands for transcranial magnetic stimulation. This method focuses on blood flow activity in a specific area of the cortex and can show us how a person behaves when the specific part of the brain is stimulated. In order to do that, researchers place a coil on a person's skull that records waves and induces an um, an electrical current, and the researcher is able to verify a function of that specific part of the brain. Thank you so much for listening to my mini lecture.